Welcome to Perl Optimization Tidbits. My name is Daina Pettit. I currently work for ZipRecruiter. And there's a couple email addresses I have. And yes, my name looks like Diana, but it's pronounced Daina. If you chop off the last A, then everybody would say Dane. So, Daina. So what we're going to do here, this is actually, if you attended Open West, I had an early version of this talk in 2017. I don't know that anybody here attended that, so you won't have to worry about repeating very much here. So the purpose of this is that we're going to look at performance differences of equivalent code. You know, Perl has this Tim Towdy thing. There is more than one way to do it. And so I'm going to look at the various ways we have to do certain things and whether it makes a difference or not. We're going to look and see if something is faster or if it has a smaller footprint. And in the end, does it actually make any difference? So some of the considerations about why we would bother with doing one version of a line of code over another is readability or maintainability. Those are usually big issues because it costs us a lot of money for somebody to sit there and figure things out. And we're going to focus primarily on language constructs. So things like, does a post auto increment like $x++, is that any better or any different than a pre-auto increment where you have $++$x? We'll talk about a few algorithmic tweaks which tend to have a bigger performance gain or loss, but we're going to not focus on that. So the assumption here is that choices matter, and it might actually make a difference here. We're assuming that the testing tools we're going to use are going to give us good enough answers to tell the difference between various lines of code. Because of some of the variation in performance of different processors and systems and so on, we're going to really just focus on the difference, not the absolute value of, say, this is 3 microseconds slower than that. It's going to say, oh, this may be 3% faster, that sort of thing, or this is 20% faster, or twice as fast. So what I used for testing, I used a couple different systems. Both had various versions of Perl 522. I know if you're using Perl 526 or 528, you might have some performance enhancements in those. There were some significant optimizations that took place in those, but is there anybody that is actually using 526 or 528 in production? Oh, a few people. Good for you. A lot of people are trapped in an older version and can't get past like 510 or so. Is anybody stuck on 510 still? That is good news. Anybody stuck below 518? I'm sorry, but it's okay. That's okay. A lot of us end up in that situation. It's because there's other dependencies that will break things, and it just is a problem. So a lot of these numbers will be comparable for all of you. We measured our performance using NYT-Prof and time. And the interesting thing is we found some deficiencies that we'll point out in the measuring of code, execution code. So the way we did this was we tried to write lines of code as simple as possible, use as few external things as we possibly could. We executed the lines of code millions of times, and then we looked at the results in the profiler. And then we looked for problems. If you switch the order of statements, does it change? If you add another type of statement in front of it, does it change? So there's a bunch of adjustments that I had to do to verify that the results were actually meaningful. So let's look at an example. So we have checking a post increment and a pre-increment against each other, running it through a loop 1,000,000 times. Now this isn't exactly what I did, but I trimmed it down so it would fit on the slide. because there were some, it turns out there's some problems they had to deal with, which I'll talk about a little later. So if we look in NYT Prof, we get some numbers here for those 2 lines of code, and we can then have something we can compare. This is not the final result of this, but this is the idea of the way we did the analysis. So let's look at case number 1, auto increment or decrement with the pre and post, what we ended up with. So we have the plus plus on either side, we have a minus minus on either side, and then we did strings. And so a lot of you may not know that you can actually auto increment a string, and sometimes that makes no sense whatsoever. But it can, if you have a G and you want to turn it into an H, you can actually do a plus plus on it and it'll turn it into an H. So there is some use for that, some call for that, but not a lot. So what we came up with is that the pre-increment is actually slightly faster. And in decrements, the pre-decrement is slightly faster. And where we're doing the increment on strings, the post-increment is twice as fast as the pre-increment, which is kind of the opposite of what you might think. And the interesting thing is that the alphabetic or the string increments or decrements are twice as slow as the numeric ones. And we would expect that because it has to figure out what character it is and modify that. So that makes it a little bit of a problem. So this one is actually surprising to me because I expected that it would be the post increment that would be faster, but it's the pre-increments that's faster, just slightly. And I think most instances of code people use the post increment. In Perl best practices, Damien suggested you always putting an XMS on the end of all your regular expression as your options or your switches. And I disagreed with that. If you can look at my talk on Perl's worst best practices, and I consider this one of the worst best practices. And I demonstrated that it was actually a bad idea because it turns out it actually has a 3% hit when you throw those on there. It's not free. And it also, but the biggest hit on that particular thing is that it takes you longer to read that code because you're thinking, now why is the X on there? And why is the S on there? And why is the M on there? So I do not recommend using that. Case 3, a for versus a for each. For and for each are supposed to be synonyms, and are they really? The answer is probably. Their performance is actually really close. A for each might be slightly faster, but it's not enough to actually say it is faster definitively. Now let's make a little bit of a change on that. Let's throw in a looping variable. So we have a mide variable as our looping variable. Does that make a difference? Again, the speed is nearly identical. There's less than 1% difference, so it's probably within a margin of error, so we wouldn't worry about that. Let's compare case 5, for versus for each versus a map, because there's a lot of things you can do with any one of them that's the same. And it turns out that map is 30% slower. Anybody have a reason why they think it might be slower? What's that? It's actually constructing something to return. That's exactly right. It's slower because it's not intended to be used in the same way. Map is best for creating lists. A for each is best for modifying existing lists. So the map is actually building something. If you call map in a void context, meaning you're not catching what it's returning, then it has to build that. Now, I believe that the map at one point recognizes when it's in a void context and does not create the list. Yes, Sawyer?
Have you compared this on an expression map instead of a block map?
In this case, no. I've just done it under the block. Again, this in Perl best practices, he recommends always using the block, but I think that's a good another good test that I could do. Good question. How about what I like to call a verbal knot versus the logical knot? They're both logical knots, but one's a lower precedence. NOT is lower precedence than the exclamation point. You'd think they'd be similar. They are. Let's look at ands, the verbal and versus the symbolic and. 20% slower than the verbal and. There's a lot of cases where we use ands, these logical ands, where these are completely interchangeable. A lot of places, so there's some places where they are not, because of the precedence issue. So just be aware that the verbal and is a little bit faster. How about an or? Again, the verbal or is faster. And it turns out that the or is actually twice as fast as an and. Now, it's hard to compare some of these things because you have to make sure the cases are equivalent. Case 9, string interpolation. Is there a difference? This is surprising. A double-quoted string is actually faster than doing a straight assignment. This one, I've been puzzled about this one. Why is this the case? And I don't know. But it's one of those curious things. Yes?
Just refresh me, which version of Perl are you using?
This is 522. Maybe they fixed this in 526 or 28. Comparing double-quoted versus single-quoted strings. With no interpolation going on inside the strings, the double-quoted string is almost always significantly faster. So if you have a choice between using single and double quotes, you might want to use double quotes all the time. I know there's a philosophy that you always use single quotes unless you know you have interpolation going on. Or you only use, the alternate is that you only use single-quoted strings when you know you do not want to interpolate. So this would suggest that we would always want to use the double-quoted strings. Now here's kind of an interesting one, where we take a string where we're constructing something in the string with interpolation going on, and we're using the curly braces to set off the name of the variable we're going to be interpolating. I would think that the curly brace form would be slower, but it turns out it's faster.
That should be solved in compile time. And so it doesn't make sense.
There's some of these things that don't make sense, but that's the way they are. That's the way the test showed. Now, I did a lot of isolation of this, and I put statements around them, so I was making sure it wasn't doing any sort of caching to make sure that it was as clean as I could get. But there's some of these that are like this that I just scratched my head and I go, I can't figure out why, but it seems to be that this is the way it is.
There is now a tool in Bleed, and I've forgotten what release it was in called. It's in the porting subdirectory called Bench. There's several of them. And it actually uses cache grind to look at the instructions. And I've taken to using that as the best way of doing benchmarking and doing comparison, because it tells you you don't need to do lots of repetitions.
Mm-hmm.
This tells you how many conditionals you had, how many conditionals you had that branch prediction failed on. So anyway,
That's a good idea. Further research.
yeah.
Yeah.
Sorry. But see, that's why this code is
So, interesting stuff. So using a string concatenate operator, do something similar to create a string that has a $y in it. And if we put the interpolation, or put the variable on the left side of the concatenate, is it faster than having it on the right? And it turns out having it on the left is actually significantly faster. That's actually a good question, and I don't know the answer to that. I don't know if it's true for all values of y. I did find some things interesting, is that in modifying some things that seemed external to the problem or should have been a minor part of the test case, ended up having a significant impact on the performance. And I'll talk about some of those later that I found that. Most of them, it didn't seem to make any difference. Let's look at scope. So if we just create a scope for nothing more than just doing scope, it turns out it has a significant hit. And we would expect that. We would expect a hit for doing scope. If we're doing scope and we have a my involved, it actually is a little bit better. Instead of 300%, it's 200%. If we use local with scope, is it any different? It turns out it is. It's about 20%, so it's a lot better. So my is actually kind of expensive. But in the case of here, if we're comparing, the local costs 20% more than the my. At case 16, we mask an existing my declaration. So we have two different $x's, two different x's. What does that do? It turns out masking a variable with a my costs us about 15%. I'm not sure why we would do that all the time, but sometimes we need to do that. Yes, question?
That's in comparison with creating a completely separate variable?
This is where you're creating a separate variable that masks one that's at the outside scope.
But it's 15% over, what's the alternate case?
The alternate case would be not having the my in there at all, or having a different variable. So if we say my y, it would be 15% more expensive to do my x. We have a lot of different ways we can get subroutine arguments. We can get it through a shift. We can get it through directly accessing the parameter variable, the @_ variable array, or by doing an assignment directly out of that as a group. Before doing the analysis on this, I was guessing that the shift was the most expensive because it requires a separate call. It turns out the array assignment is the slowest. The direct indexing into the array, the parameter array element, is the fastest. And shift actually isn't that expensive. So that's actually good news, because a lot of code, I see shifts all over the place, and I was worrying, hey, is this a performance hit? Turns out it's not that bad. Let's look at alternate control structures. Some people like these, some people hate them, some people didn't know you could do this. So you have an if, or you use an and. They both have a scope that's created with the code block, but these results are exactly the same. And when we ran the analysis on it, identical performance. So you don't need to use the and form for performance purposes. An if is just as good. Why would you use one over another?
If it's readable.
You know, yeah, and there's some instances where you may want to use one over the other. So the if where the if is the only thing there, then yeah, that's probably the most readable. However, there was a project I worked on for one company where they were generating, they were creating a big long string. It was essentially going to be a big buffer that we needed to pass to a program that was going to generate a PDF from it. And so it had to be a big long string, so we're doing lots of concatenation of things onto a single string. And what we ended up doing is basically saying if it's this case, then we concatenate this on. If there's this other case, then we want to do this other one. And it would have been really ugly to have if-else-ifs just chained one after another. And using the AND form and then having everything line up in nice columns was really clean. It really worked well, but it's because we had hundreds of these lines all in a row, and having hundreds of ifs in a row would have been just a nightmare to maintain. So it actually worked out really clean. So there are reasons why you might want to go one way or another, but most of the time I think people would just use an if. We have a question over here.
I was going to say that if, actually, variable and to deparses to if.
Yeah.
So,
Yeah, it's probably the people optimizer making these generate identity.
Yeah. So it ends up, it's the same thing underneath. Yeah. If we look at an alternate of something like that, where we have the else case, it turns out that the do form is actually 40% faster. I'm not sure I'd recommend that form for readability, but it's interesting that there's a bit of a hit there.
Each has English and in or versus logical and in or?
In this case, I did not, and maybe I should have, because that in the earlier testing, it appeared to be a big difference. So that may be another route to go. And likewise, why would you do one over the other? And it really boils down to what do you need? There may be a case where it looks good to do things in nice columns. There might be a case where you just an if-else makes a lot more sense. And I think most cases you just want an if-else. Case 20. Do we want to use a return or not? It turns out using an explicit return is actually a little bit slower. Not a lot. Yes, Sawyer.
This would result in a later version. This would result in a later version.
Yes. So,
I don't know which try and phrase it.
so let's look at printing a list. So we do a call to a print statement, giving it a list of things to print, or doing separate print statements. We would expect the multiple print statements to take a little longer because you're doing two separate calls. Printing a list is actually faster than doing them separately. However, if we do a print with a join, is that faster than using a print and using the $, list separator and letting print insert that dash? Turns out using join is slightly faster, but it wasn't really consistent in the testing I did. So it wasn't enough to say, yeah, always use join. Case 23, array versus hash speed. So this is comparing a little bit of apples and oranges here, because you usually don't index the same way, because it's two different. One indexes by an integer and one indexes by a string. But if we were to compare them, giving him the same type of thing to index with, like an integer or an integer string, which would be faster, it turns, and I've always been told, oh, hashes are really fast. That's why we use hashes so much. They're just so fast. It turns out hashes are actually slower than indexing into a hash is slower than indexing into an array. So if you have a choice, if it matters, you might want to use an array. Yeah, we tried to simplify the cases.
How long was the number? Was it a single digit?
I'd have to go look up the test case again. I think it wasn't a big number. It was a small number, like a single digit. So in that case, we're looking more at the overhead of what it takes to access the hash rather than computing the index. So should we use strict or not? Does it matter? And of course, everybody says, oh, you got to use strict, and you probably do. But if you really don't need to and you need to squeeze the last bit of performance, does it make any difference? Well, it turns out that my statements are slow. So if you don't use strict and you don't use my, it'll actually be faster, and it's about twice as slow. So there could be a good reason to not actually use strict if you really need to squeeze out some performance here. And what was interesting is that almost any access of a MIDE variable was slower than accessing one that was not. Occasionally you'll run into somebody who uses what I call an inside-out for each, where there's a single statement that's terminated with a for each. And it's essentially the same thing as a regular for each, but it's got the single statement on the outside. And the difference, it turns out, is that the standard form with the code block, the 3-line form that we have here, is 50% slower. Anybody have a reason why? Scope. That's right. It is scope. It has to create the scope for that for each. So although I think the inside-out form is kind of ugly and it's not as nice for reading it, it actually does help you if you don't need the scope.
Is that a one-time setup cost? So if I was going from 1 to a billion, it wouldn't matter versus 1 to 10, where it's a relatively short operation?
That's a good question, and I don't recall the answer to that one.
It matters per iteration.
It matters per iteration. Yeah, it turns out there's some funny things we'll talk about. See, a for each isn't just as clean as it looks on the page, because there's more stuff that goes on when you're going into it and then when you get to the end of the loop. And that stuff has to be handled, which you don't have in the inside-out form. Let's look at ternary operator alternatives. I have 3 here, and some of these are kind of obtuse. I don't know that anybody has seen these that much, but they're out there. I actually stole this code from somebody, and it was some production code. So it actually does exist. So there's 3 different forms. The idea is that if our x is equal to y, that's a string equality test, then we want w to contain z. Otherwise, we want it to have an empty string. So the if-else form is pretty obvious how that works. The ternary, you should all be familiar with that. The last one is just, it's looking at that double ampersand, evaluating the left-hand side of it first as a Boolean test there, and then if that's true, then it goes and does the right-hand side, which evaluates the z, which then assigns the z to the w. But if it doesn't, it's false, then the value is going to be an empty string, which then assigns to w. So these are equivalent. So it turns out The if is slowest, and we would expect that due to scoping. The ternary is usually fastest, but the biggest difference has to do with how complex our conditional is. So if we make our conditional more complex, then it may turn out that the ternary form is actually slower. But the bottom two are pretty close, it turns out. Let's look at indirection. So if we're indexing into a hash, or we have a hash ref that we index into, how much performance hit do we have with that one level of indirection? And it turns out that indirection is only slightly slower. It's almost imperceptible. In the measuring I did, there was really very little difference, but in any measurement there was a slight difference that indirection does cost something, but it's very small. However, if you have multiple indirections, or if a statement within an index to the hash is complex, then it starts getting ugly and actually can be quite slow. I had a case where there were 3 levels of indirection, and it took about 5 times as long, which was puzzling to me that it kind of ballooned like that. Also, there's a difference when you're using indirection. If you're accessing a value using that indirection, then that's pretty fast. But if you're setting a value using indirection, it's slower, significantly slower. Should we have warnings? Should we turn on warnings? Of course we should. But does it cost us anything? It turns out there is a slight slowdown if we turn warnings on, and we have a slightly larger memory footprint, but it's not enough that anybody should care. It's pretty minor. Yes?
The question in general, maybe you said this at the beginning about whether I should care about any of this, because a 20% slowdown of something that takes 2 microseconds is still insignificant, right? Just the percentages don't mean anything. And if it's taking a tiny percentage of my entire program, why should I care about any of this? I mean, it's interesting to me with the core developers, but why is like a regular developer should I even
What if you have a
this?
program that runs 17 hours?
Why are you writing it in Perl then?
Of course, right. Of course, and then you do, but even in a case where it takes 17 hours, generally just a small part of it is taking all that time. And this may or may not help you.
Yeah, and I don't want to quite jump ahead to the conclusion, but yeah, this is Perl optimization tidbits. So it's just little tiny things that if you combine them, the best of them all together, maybe you'll get like a 3% improvement in your runtime. Most time it doesn't matter. There's an excellent talk that was given by Tim Bunce at Orlando in 2014, I think that's when it was, and about optimization and profiling, and he talked about his NYT prof, and he emphasized again and again in his talk, do not optimize, do not optimize. But if you do, here's how you can figure out how to do it. But don't do it. And I agree, most of the time we don't need to worry about this. This talk is mostly for interest, curiosity. Does it really make any difference what you do? It's nice to know that things are not a big hit or that it doesn't matter. Let's continue on. We're actually almost to that point here. So should we comment our code? Of course we should comment our code, but how much of a hit is it to actually comment our code? So I ran a case where I had 100,000 lines of comments and then a couple lines of code. And it turns out, even with that huge amount of comments, the difference was almost unmeasurable. It was measurable, but it was so small that it made it, because I always thought comments would be, you know, if you had 5,000 lines of comments in a 10,000 line file, that it would make some difference. It turns out it's almost no difference at all. The comments are clearly worth doing. Case 30. They're not macho. They're not macho. Yes. Although I do know of a case, this is not a Perl programming case. I worked with a guy who had actually 10,000 lines of code to about 30 lines of code, or so 10,000 lines of comments to 30 lines of code. It was written in Ada, and he had written a tool to strip comments out so you could actually see the code. And I thought that was kind of serious overkill. But just beware, comments don't hurt you that much at all. Let's look at doing a split versus a regular expression. Now there's a lot of variables in here because if your regular expression gets complicated, it's going to probably hit both the split and your regular expression by itself. So if we compare these two, and I'm not showing a particular regular expression in here, I'm just kind of leaving that blank. You have to do captures in there and all that sort of thing. It turns out if you do that the regular expression is actually faster. And then if you use M and G, regular expression suffixes, it's even faster. So split is very handy. It's nice to read. It's very maintainable. Regular expressions are harder, but you do get better performance out of the regular expressions. Now, one of the algorithmic solutions is to do slurping instead of reading record-based or doing record-based input. What this does is it minimizes our disk cache. So instead of hitting the disk for every time we want to do a read or hitting our disk cache, we only hit it once. If you have small amount of data you're reading, like a file of 100 or even 1,000 lines, it probably won't make any difference. But if you have a 2 gigabyte file that you're processing, it's a log file, it could make a big difference. But you need to make sure you don't overflow your RAM and end up going to swap. I had a guy I knew who he had every day had to process 2 gig of log files, and he was reading them a record at a time. And it took about an hour for it to process that 2 gig. He switched it to doing a slurp. So he'd slurp that whole file into RAM, and then he would process it in RAM. And it knocked it down to about a minute. So it can make a huge difference. But with small files, you won't be able to tell.
Interesting thing here is actually if you're using Perl I/O, it's going to read in 8K chunks. If you bypass Perl I/O, it can read much larger chunks and make a big difference.
Yeah, so he said that if you use Perl I/O, it reads it in 8K chunks. So it'll affect your performance there as well. Now let's talk about some of the weaknesses in testing. NYT-Prof tends to over-allocate time to the last statement in a block. And that's because there's stuff that needs to wrap up at the end of the block, and instead of just attaching it to the closing brace, it attaches it to the last statement in the block, no matter what it is. So that's a problem. So I had to make sure I had dummy statements that weren't doing anything that I was testing as the last statement in a code block. There's probably some other funny things about NYT-Prof. It's my daughter. There's probably some other funny things in NYT-Prof that we don't know about, the little quirks. So that's a little thing that might be a problem. Also, there are some invisible internal Perl optimizations. Statement order actually does matter, and it's hard to quantify the actual value of each line. And then, of course, the recent releases probably have some optimizations in there that will invalidate some of this data. But the summary is, most of this doesn't matter. The things that we learned from this is that scoping actually do cost us something. so that we shouldn't use unnecessary scope. Most of us don't, so that wouldn't be an issue. But beware that scoping does cost, and that we really should focus on the human cost. That's the real expensive part of what we do, and that's our maintenance and readability. In almost all cases, nothing else matters. And the biggest optimizations gains we're going to get isn't due to picking a poster increment versus a pre-increment. It's going to be an algorithmic change. Those are where the big performance gains are. However, if you really do need to optimize and you've tweaked absolutely everything else, this gives you some informed choices. If you want further information, you can go to the Perl doc stuff for NYT Prof, benchmark. You can also look at some optimizations of sorting algorithms. I have a presentation at the May 2014 Open West. That's available on YouTube. Streamlining and simplifying your Perl code using map, grep, and sort. Do we have any comments or questions? Yes.
Another lesson is that developers are almost always wrong about what they think about performance, where they think.
You know what? I agree, and I've been telling people that for years, because every time I looked at some code that I felt needed to be optimized, I would say, oh, it's got to be in the I/O, or it's got to be in this or that. And then when I actually profile it, I find out it's somewhere else. And it's usually not where I expected.
I mean, how many people guessed right? Most of them. Here. I haven't seen maybe Shy or Roger. Something else. What?
Most of the time I run a profile and points to something else, but I was thinking
Yeah. And there's a great statement that's attributed to lots of different people, Tony Hoare or Donald Knuth, go figure, I don't know who actually said it, but it was premature optimization is the root of all evil. And
It seems to be very case specific when it comes to optimization. You can't generalize. But one program it might work and in another program it doesn't.
yeah.
And it depends on the cache size. I mean,
There's lots of variables in there that will mess things up and change the whole thing is very dynamic. Yes?
Yeah, an example that I've run into repeatedly is when you're looking at an isolated subroutine in a module that's used in a variety of contexts, it may or may not look slow at first examination, or you may benchmark it and say, well, I can probably make it faster, but it'd be less readable. And that's fine if the usage of it tends to be fairly light. But it turns out maybe somewhere else in your code base it's used in a tight loop that executes millions of times, then you'll see it when you profile the larger application, but when you're looking at the profiling or benchmarking of that routine or that small module, it didn't really show up on the radar. So that's the other thing that can surprise people is the author of the code may not always understand the use cases, especially when they come 2 or 3 years down the road in the future. The profiling can sometimes reveal surprising things in that area.
Exactly. So profiling really is key if you need to optimize. There's no way around that. Yes? Yes. Yes.
Did you look at larger lists of parameters? So instead of shifting off just the first one, you're shifting off 3 or 4 in a row, just compared to a single array assignment?
In that case, I did not check for doing shift. In those cases, I mean, my preference has always been to grab them all as a list, and just have a list on the left-hand side that's got the variables MIDE. They all have the name. I'm not pulling them off in some sort of array. That way, it's real clean. And that was also because I thought I was uncomfortable with shift. I'm not uncomfortable with shift anymore. But there is something a little bit uncomfortable about shift is it operates on different things depending on its context. So that could be a little problem. We'll go to the, do you want?
It's more a comment than a question, but I have the feeling that even if most of what you say is true, it's pretty not, it pretty also depend on the bare version you are using. It's also pretty depend on the way you're benchmarking. Benchmarking is probably, it's pretty hard. I don't know if you use duck bench. benchmarking. Like I was trying to put the 50% benchmark for the foreach, and I could not get that level of 50% delta between a plus in one line on the block. So I'm not sure that the gap is so important depending on what Perl version you are using and how you are benchmarking.
Yeah, it's benchmarking is actually really tough because there's so much external stuff that can affect it. I mean, if you have other, I mean, if it's a multi-user system and somebody decides to log on while you're benchmarking, yeah, good luck with that because you just got swapped out.
So that's why cache grind, you should rerun these things with cache grind.
Yeah.
Using, which is, and the porting benchmark tools that do that. And that's how I do all my benchmarking now.
Sawyer?
So just other than Carl's recommendation for Perl, I really recommend to avoid benchmark.pm. There's a post on how David Golding compared A to J doing the exact same thing, and J was way slower.
Mm-hmm.
Because of all the things you mentioned. There's a module called dumbbench, and it does pre-runs, it does a bunch of stuff, and it's mathematically much more accurate.
And it's called pre-bench?
It's called
Dumbbench.
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 Definitely.
Okay.
U-M-B-B-E-N.
Okay.
But it's still, cache grind's a lot better.
Yeah. Carl suggested is I'd say the higher bar, but definitely benchmark PM gives sometimes completely wrong results because of the problems you mentioned.
Yeah.
Dumbbench is better.
It's not as dumb.
Wait, yeah.
So
Yes.
one thing, you might, this is just, I'll just say it. So in 528, I've added some things that, like, if you were, it's very data dependent, depending on the bit patterns. So like an A and a B have 2 bits differing, but a B and a C only have the letters. If you look at their hexadecimal or octal
Sure.
binary representation. A B and a C only have 1 bit different, and therefore a whole different set of things will kick in and be much faster. And you would never know that if you're doing a string like $X versus $Y, but it's just so data dependent. And
You're right. There's a lot of the tests that are very data dependent, and it's hard to know without actually inspecting the code underneath to see exactly what's going on. Because I ran into funny cases like that where I go, why is this acting so strange? I change this one thing, and all of a sudden it balloons.
right. And so like in Programming Perl book, there's an example of how this regex will not finish until after the heat death of the universe. And it uses, A star, A star, A star as a match and stuff. And it matches A versus B. And that will still in 528 and 30. But I'm planning to change 530, so it uses this new technique. So if that was a B and a C, it would fail immediately.
Mm-hmm.
But in A and B, it will not match until the heat death of the universe. So, just because there's 2 bits of difference in A and B, and 1 bit of difference between B and C.
Yeah.
So
That's interesting.
A huge difference between immediate and forever
Sure.
for 1 bit.
Well, that's it. We're out of time. I want to thank Larry for Perl to begin with, and Bluehost, who I did some of the research under, and ZipRecruiter, who allowed me to continue that. And, of course, Tim Bunce for NYT Prof, which is kind of a fun tool and very useful. Thank you.